Hi, Anthony Garcia here, and I'm excited to bring you the results, or a summary results, of the LTE-BI with UC platform testing that I did. Now, I tested Microsoft Teams, Ring Central, WebEx, and BlueJeans all over LTE-BI. Not just one person. We all know that over LTE, one person is going to work, but multiple people over LTE-BI. And not only that, capturing all the data, how much bandwidth and things like that that individual users are going to use based on what meeting platforms and how they're holding those meetings and things like that. And what this did is kind of led me down a few particular roads that I want to share with you. Now, I'm no RF engineer, but it really led me down and opened up some doors for me as a UC guy to what I need to watch out for, what I need to be confident about, and talking to customers about UC when we're using LTE-BI. So join me. So let's get to the why we did this. We really wanted to understand the impact of UC applications over LTE-BI. Now, I'm not talking about the one user scenario like you use on your mobile phone. We all know that BlueJeans works or WebEx meetings work on a one user device like a mobile phone. We more were after the enterprise. How many users, for example, can I support over LTE-BI if I'm using Microsoft Teams at a location, or WebEx, or BlueJeans? And what things, if any, did we need to get a better quality of experience for a customer that's going to use one of these UC platforms over LTE-BI? So how we tested? We tested the UC platforms like Microsoft Teams, Ring Central, BlueJeans, WebEx. We used subjective testing, so we had 7 participants. We did over 40 meetings with these 7 participants, and then we gathered real-time data usage during these meetings on the LTE-BI circuit. We tested meetings and data usage from different locations, so we moved the UE, the user equipment, the modem, the router, to different locations and different distances from the tower. We conducted a professional site survey to discover the RSRP, RSRQ, and SINAR statistics. We used different professional grade antennas along with the site survey to gather important RF information. We used different QoS methods to see if any were more favorable to the LTE transport. And we collaborated with other professionals within our company and outside our company to ensure that the results we were seeing were legitimate. So just to get a quick visual of the participants and the users that we used when joining these different platform meetings, is we had the LTE router here, and we had 3 users on the LAN side of LTE. We both used Ethernet and wireless. And then we had a probe connected to the LTE side, watching that bandwidth. And then all the rest of the users are out here on the internet, some wired and some also LTE users. So what are the outcomes here? Well, as far as data usage, let's get one thing clear. All these UC platforms have data management features where, based on delay and loss of the transport, these platforms will downgrade their video solution, frame rate, etc. What we were really after here is, given enough bandwidth, how much bandwidth would a participant meeting endpoint use? The conclusion is that the UC platforms have varying data speeds based on many variables that the participants of the meeting control. For example, if a participant uses Microsoft Teams Together mode, or maybe they like to change into gallery view and they like a 2x2 or a 3x3 gallery view, or they like active speaker view. All these things have different data usage profiles. Another example is sharing content. Well, it was no surprise that when you start sharing content, all the data speed goes down, but it goes up when a participant has dual screens and puts the shared content on one screen and maybe an active speaker or gallery view on another screen. Now, based on the empirical data that I gathered, it leads me to the opinion that daily usage is not something you can calculate with any degree of accuracy. Can you take a swag at it? Yes. Many UC platform vendors out there have their calculators on their websites. Some even go to some granularity in breaking out audio conferencing, audio video conferencing, audio video and screen sharing, and things like that. However, let me try to prove my point with this graphic. Let's look at this graphic right here. This is a Microsoft Teams meeting. 3 people on the LTE-BI side, in other words, on the LAN side of LTE-BI. The rest of the 4 people that are participating in this meeting are out on the internet somewhere. Now, let's look at that. That's 12 megabits per second, right? You can see here's 9. You can see here this is 6. What I'm doing in this testing is changing the layout in one of the participants that are on the LAN side of LTE-BI. So I'm just showing you this because the data differences, the deltas in changing these ways that people consume their meetings on their PCs or Macs is significant. It's not some small variation. It is significant. Based on one participant changing something, the data rate or data consumption went down. Silver lining here, one platform kind of stood out, and that was Microsoft Teams with its meeting policy that allowed a policy to be given to users or groups of users, and it kind of capped the bandwidth that a particular participant can use during a meeting. Doesn't matter how they consume their meeting. 2 screens, together mode, gallery view by 2x2, 4x4, 8x8, doesn't matter. Microsoft Teams is able to cap the bandwidth usage for particular users. And that's significant when you're talking about LTE-BI and data caps. Now, I should say here that some of the other UC platforms did have some client-side knobs in their clients where you could choose to scale down the number of participants that you see in a gallery view, let's say, and then you could choose not to use HD video, things like that. Again, those were client-side, and there was very little mechanisms from a sysadmin point of view, from an admin portal. Definitely not anything as significant and as good as the Microsoft Teams meeting policy. Okay, let's take a look at this graph. And this is the same meeting or a similar meeting as this right here. So remember, we had 7 participants here. These are the same 7 participants here, again looking at the LTE-BI circuit. And now we've applied a Microsoft Teams meeting policy at 500 kilobits per user. Now you can see that we can definitely drive down the data usage for Microsoft Teams meetings. Now, obviously, in this scenario, we're going to have less video resolution, less frame rate on our shared content. The shining star here, Microsoft Teams, with its meeting policy, you can control data usage much better than you can the other UC platforms. One thing that I want to point to is right here. You guys might be looking over here and over here to see what was going on. Nothing more than just using some other workloads, OneDrive, email, and things like that. Okay, let's switch to LTE speed testing. Now, I'm not going to go into what category of router, 18, 19, whatever. What I will tell you, with UC, we all know that if we want the best results, we want the best user equipment. More MIMO is better. This is not the place to skimp on caliber of router, the vendor of router, and the features for that router. Now, UC recommendations and recommendations of routers, I'm not going to get into. That's going to be in a separate talk. We're going to talk speeds here, but I want to get that out of the way. Okay, that's all I have to say about that. So the testing results identified that LTE speeds are constantly in flux. Now, I have been on LTE for the last 10 years. I knew there was going to be some fluctuation in speeds. The nature of RF is just the nature of RF. You can't mess with physics. LTE speeds are constantly going to be in flux because RF is constantly in flux. There's tower congestion. How many people connect to the tower actually have to do with speeds for people connected to that tower. Foliage, winter foliage versus summer foliage. Damp foliage versus dry foliage. That makes a big difference. Line of sight obstructions to the tower, surrounding structures, etc., all affect RF. Let me turn your attention to this little graphic right here. I took tests with a category 18 router, that's 4x4 MIMO, at about 700 feet from a tower. I could see the tower. It was perfectly visible. There were no obstructions at all. I want to show you the testing that I did here. There's 41, 8, and 9. That's a big fluctuation. That's a big delta from 41 to 8. So what I'm trying to prove here, there are extreme deltas in speed based on RF, based on the ability to do MIMO, and that is based on the RF conditions. What stood out here was the ability to stabilize speeds. What if I get some antennas? I know in my own situation, the right type of antennas have always helped. We conducted a professional site survey, so we procured professional site survey equipment, installed professional outdoor antennas. We tested about 5 different antennas, kind of covering the whole gamut of panel unidirectionals, LPDAs, omnidirectionals, 2x2 MIMO, 4x4 MIMO, kind of all the above. And the one thing I want to say here is there's no one size fits all on antennas for UC. Again, it goes without saying that if your UE supports 4x4, you want 4 antennas up in the air, and you want these antennas outside in the best location, which the site survey will reveal. Data also showed that amplifiers also helped in stabilizing speed. Now, however, there are many variations of amplifiers. We tested 2, kind of a high-end residential one, high boost, and a semi, in the middle of the road commercial one, the Selfie Go. And all I can say here is, again, you got to fall back on the site survey, and you really got to be in the know and talking to people that really know these things very well. The people over at Nextivity can help you out on this. Definitely. They're very intelligent in what you need for speeds as far as these particular amplifiers. Never discount the site survey, even if a customer already has amplifiers. I would even submit to you that if they have amplifiers and say everything works great and we have amplifiers and we're just going to use paddle antennas on the router, that would pique my interest right away. And definitely, I would say to them, it's even more important for you to get a site survey and get in the know as far as RF situations here inside your facility. Let's turn our attention to QoS. So first we're going to take a look at traditional QoS methods, and then we'll take a look at Cradlepoint and this new thing called FQ Codel. Before we get into the traditional and FQ Codel strategies, let me do the bad QoS strategy for multi-users. All right, the bad strategy is do nothing and hope for the best. That's never going to work out for multi-user. I caution against it. However, there's a good chance of success for a single user. Done some tests with this. Things look okay. If it's a single user, you're going to have enough bandwidth and things like that. And unless you're very, very heavy multitasker, you're going to be okay in this situation. So what happens with this strategy, which is a Fifo strategy? Well, just real quick, we have the incoming gig LAN, very fast LAN on this side. Remember, we have our variable speed LTE-BI circuit on this side, and then we have the router with no configuration, just using Fifo. So what does this look like? Let's take a look. These fast packets are going to be coming into the router. They're going to get backed up, obviously, to different speeds, and we're going to drop something. And let's just say that red something there is voice, so that's going to be bad. Again, for work from home single user, this seems to work okay. I want to make that clear. Let's take a look at our good QoS strategy using traditional QoS, low latency queuing, class-based weighted fair queuing. Again, we have our gig LAN over here. We have our variable speed LTE-BI. Hopefully we've stabilize that speed, and we have our router here. Now we have to do some manual configuration, so it's no longer the do nothing plan, it's the do something plan. We're going to configure classifiers. That's going to classify our traffic as important or voice or things like that, or less important, things like that. We're going to create those classes and then put the classes in particular queues. Here's our low latency queue. Here's our Q1, Q2. As we go down here, those are less important queues or weighted less. The low latency queue is serviced more often. And then we're going to configure a bucket. Here's our bucket here. And the most important thing that we're going to configure on this bucket is a hole at the bottom of this bucket. And it's going to be a leaky bucket, and we're going to leak less than the transport speed. Again, that's why it's so important to make sure you can stabilize that transport speed, because we're going to choose a number below that transport speed because we don't want to overwhelm and lose any packets out here in the transport. We don't want anything getting backed up over here, because if they get backed up over here, we can't choose what we lose. Oh, that rhymes. We can't choose what we lose. Okay, let's see how this works here. Here comes our fast packets from our gig LAN. We've got multi-users over there using this LTE-BI circuit, using this router. We're classifying them, and then we're putting them in queues, and then from those queues we're going to put them in the bucket here. We're putting our voice first. We're going to service that. See how we service that queue more often. Here we go. We got some other traffic coming in here, and look at here. We've kind of hit our high water mark. So more configuration. Now when we hit this high water mark, we have some configuration on exactly what to drop, because we don't want to overwhelm this bucket. We can't fill this bucket up and have things inadvertently spill out of that bucket. That's going to be bad. We have to choose what to drop to make sure that we don't overwhelm the 29 megabits per second hole. So since we can discriminate on what to drop, we're going to drop less important stuff. There goes something less important. We certainly didn't want to drop this red stuff. And then, of course, if it's TCP, it's going to do its windowing thing and things like that. That's how we're going to do traditional QoS. This is good. We've done this in the wired world forever. We like this. We know how to do it, but it's manual configuration, again, whether it be in the router or in an SD-WAN device. Still kind of the same thing you got to do here. So why do I tell you all this? To teach you about QoS? Absolutely not. The main point here is this hole and this speed. So this is the whole reason I'm telling you about QoS strategies, is because this leak right here is reliant on this speed right here. Again, we can't have speeds, let's say the variance is 35 to 25. Well, this wouldn't work then. Or let's say we have real bad RF conditions and we didn't do antennas, didn't do our due diligence on site surveys, and we sometimes have 45 and we sometimes have 15. What do we pick for this hole? 10? Remember, this shaper is always on. It'll always shape to 10 megabits per second. If you're paying for a 50 megabit per second circuit and you go do a speed test at speedtest.net and you see 10 megabits per second, that's not going to go over too well. So I tell you all this QoS stuff because this reason right here. Let's take a look at the new kid on the block. Active Queue Management Fair Queuing Control Delay, or AQM, FQ, CODEL, CODL, you'll hear it pronounced both ways. We're back at our router here. We have nothing more than setting the auto QoS feature, which includes this FQ CODL. What's going to happen in this scenario is no configuration and set it and forget it. I like that. That's less complex, more user-friendly, and more cost-effective. Let me explain what's going to go on real quick before we see this animation. What FQ CODL is going to do is every connection, every flow that goes through the router, it's going to create a queue. And then it's going to make intelligent decisions on dropping things from those queue as to not overwhelm the transport circuit over here. Remember, we have this variable speed circuit, right, which is lower than this high speed LAN over here. Let's take a look at what's going to happen here. Here come our packets into the router. We go to these queues. Now, it's important to note here that even though I have these painted, the Router has no idea if this is voice, if this is a file transfer, and so on and so forth. However, there's some very complex algorithms in FQCoddle, and in a nutshell, it's going to automatically promote sparse flows. Well, guess what? Most latency sensitive traffic is sparse. So it lends itself to delay sensitive real-time traffic. What do I mean by that? Well, let's go ahead and play this out. We're going to put this stuff on the transport and we're going to favor that sparse flow. Again, it doesn't know that that's voice at all. Now, what else is really cool here that has a lot of promise? It doesn't matter how fast this circuit is. Remember, we had the leaky bucket before, and we really had to concentrate on antennas, RF stuff, to make sure that the transport speed was very consistent. Now, we still have to do that here, but it's less important if we have this FQCoddle, because it's going to compensate, and it's going to, all it knows is it's queuing up stuff. And if it can't get out because, let's say, this thing is slow right now, or maybe it's fast later, it doesn't matter what speed it is, it's going to look at these queues and favor low latency traffic. And that's the easiest way to explain active queue management, fair queuing, control, delay. So a bit of caution on the FQCoddle. I'm very hesitant to put things in presentations and in talks if I haven't configured it and seen it work myself. I haven't been able to get this to work in the lab yet, but I am working with Cradlepoint weekly to try to get this configured and to see what it's all about and if it's going to do what it promises. So I will let you know, and I just wanted to be honest in this video. Okay, let's wrap this up here. Data usage. Obviously, Microsoft Teams wins the day here with the Microsoft Teams policy. Other UC platforms do have some controls, but they're mostly on the client side. So obviously, there's going to be training or some kind of company policy to make that happen on the client side. We talked about LTE speeds. This is an important one. We don't want to skimp. We want site surveys. We want good antennas up in the air. We want good routers with good feature sets. We talked about QoS. Remember, the traditional way, which I like, and everyone's very familiar with, and we have this new guy on the block, FQCoddle. The jury is still out there, but it looks promising. Now, what does all this wrap up to be? I believe the silver lining in here is 5G. You see I'm missing 4. I put 5 for 5G, because if we do site surveys, we're going to have good antennas. When we do the antennas, we make sure they're wideband antennas and they're able to cover that C-band also, so we can cover that. We're going to make sure we have good routers, right? We're going to get premium routers to lend themselves to better UC and stabilized speeds. These routers, 5G upgradable is where I would go there. All right, we're going to have antennas up in the air already. That's going to be critical for 5G. So I contend that we do all this, and the story I see revealed in this is we're really getting ready for that 5G. So I hope this has been educational for you, and thanks for watching.